Bro, it was crazy. I got to play the Jig 2 solo upside down. It was crazy. Do you free tomorrow? Wanna go to the mall? Nowhere. Ghost Town in Newark. Of course, Hayward. You wanna go? Alright, dude. I won't be awake till like 2, because I'll be honest, I gotta get my rest, alright? See you tomorrow. Who's on my chair? I knew you'd wake up eventually. Hey, who are you? I'm Brian Walters. And you're under arrest. I'm under arrest? For being too stupid. But I'm not dumb. Oh yeah? What's 16 squared? Wait, what's your name just one more time? Brian Walters. Opposite of you. Nice to meet you too, I guess. Now, what's 16 squared? I think anyone would need like a calculator or something to answer that question. Sounds like something a dumb person would say. I'm just pointing it out there. Just me personally. Would you just call me? No, don't be offended by it. Some people just don't go to college. They just end up on the street and they're all, Huh? Wait, so why are you here though? Now listen, I got sent over here by a teacher, Mr. Dominguez. And I'll admit, he's a chill dude. But he's really worried about you. Okay, you're failing his class. Well, okay, but what does that have to do with me? Well, what do you think? I'm just gonna let you sleep here, groping about some extracurricular intercourse? I'm not about that, okay? See, I like smart people. And I don't like you. So you just came here to brag? No, bragging's for losers. Do you brag a lot? Excuse me? No, I wasn't saying you did, but like... No, that's not what I meant. Huh? Alright, so what do I have to do with this, though? Listen, I came over here to teach you some math, okay? And if you can't answer 16 squared... Okay, no, but ask me the question again isn't gonna help. I still need, like, a calculator to solve that, though. And that just proves to me that you're dumb. Dude, whatever. Now listen, if you follow me to the other room, I got a math assignment that's just perfect. Bro, it's 5 a.m. and you just woke me up. And you expect me to do math when my brain is still waking up. I don't know what you expect me to do, but I'm not gonna do it. Well... Okay, there goes that. I guess I'll go home. Get your... Here's your packet. Okay. Hey, that's Ike. What's up? Hey, you said Ike? Huh? Wait, so how do you expect me to do this? Just go to a random page and do the problems. Okay, I landed on probability. The first thing you need to know when you're looking for probabilities is being able to find a percent. So what percent of 12 is 9? Well, we're going to use this equation right here that you can definitely see. We're going to substitute 9 for A and W for 12. And now we're going to multiply this entire equation by 100. So let's go ahead and do that. And we all know the fraction 9 over 12 equals, we all know this, 0.75. Multiply by 100, you bring the decimal 2 places to the right, you get 75 equals what? Well, 100, and that leaves you with P, and then down here, 75 equals P, but P equals percent, so that's 75% of 12 is 9. I'm going to give you all a problem to do at home, all right? What is 30% of 6? I'll give you some time to figure it out. You should have gotten 20%. Another thing not to get confused with is if questions say, what is 6% of 30 or what is 30% of 6? Oh, that's probably why I landed on 500. Thank you for rudely interrupting me trying to make a histogram. See, look, how a histogram works is instead of going like a slope in a graph, it just has little bundles of things. and in different increments. So it brings like more of a clock of a data. It's not yet a slope, but you can still draw a best fit line through it. So since I just did one, I'm not gonna make you do one at home. Okay, so how do I know what those people think or what's likely to happen in a situation? The most useful thing that you've said in your life. This right here is a probability scale, and it's pretty easy to remember, so I'm just gonna get rid of it. Wait, no. Too late, let's give some examples. Now, there's this thing called a meteoroid. Just like that. Now, those of you who are into astrology, they may know about meteoroids or asteroids running across our night sky. But what's the actual mathematical probability of them hitting Earth? Well, let's find out. Like I said, we have a meteoroid. The probability of impact is 0.75%. And the flyby date is any day. So that means at any given day, there is a 0.75% chance that a meteoroid is going to hit Earth. Using our invisible probability scale, that would probably be likely. Let's do another one. There's this thing called an apophis. Apophis. The flyby date would be 2029. And the probability of impact is 0%. So that means 0% probability that the apophis is going to hit Earth. Now, for those of you who are like science nerds or space nerds, are you a space nerd? You're not a space nerd. No one here is a space nerd. You may know about the 2000 SG344. All right? Its flyby date is 2068 to 2100. All right? And the probability of impact is 1 out of 435. Now, that as a decimal, no one knows. But we do know one of these, every 435 of them, only one of them is going to hit the Earth's atmosphere. Got it? Yeah, I think so. No interrupting, please. Thank you. Now, we're going to talk about something that's called a probability experiment. Do you know what a probability experiment is? Are you going to interrupt? I'm going to make a probability experiment over how much you interrupt me. Very likely to certain. Anyways, a probability experiment is when you want to find out all the possible outcomes. For example, if you flip a coin. Get over here. Yo, I just want to leave, bro.
Nah, I don't want to leave.
Want a coin flip for it?
Sure.
I call heads for leaving.
I call tails for staying.
Damn it.
And then roll a 6-sided die.
How about a 6-sided die roll?
I call numbers 3 to 6.
I call 1 to 3. 6. Damn.
There are 13 things that may occur. One of them is being hit by a plane falling down from the sky.
What?
The other 12 things are listed here on the board. If you hit heads, that means you could have rolled any one of these 6 numbers of the die with the head probability. If you lose a bet and happen to land on tails, then you have the other 6 here as well. And there are also these things called favorable outcomes. It means outcomes that you want to happen over anything else happening. And I know you're all wondering, how do we put this into an equation? So let's say you have 4 true or false questions and you want to know what the probability is of only getting 2 of them right. Well, if you get 2 right, then there would be 6 favorable outcomes. Why are you on your phone? So since there is a total of 16 all outcomes, and there are only 6 that we want, then that is 6 over 16, which simplifies to 3 over 8. And we all know, everybody knows, the fraction 3 over 8 is 37.5. And that is the percent that we get 2 answers correct. Hey, if I could make a comment, I think I'm kind of getting it now. Nice, good for you. Where did you come from? I've been here the whole time. Okay, then. All right, but are you actually understanding this stuff? I mean, yeah, I kind of understand what he's saying. Good. Hey, I want to give you this green shiesty as a gift. Thanks, I guess, but doesn't Brian already have one? Now look at this here. This is the equation for a compliment, something which you haven't given me. Well, I could if you give me the chance to talk. As well as something in a probability that is true or false. If you want to find something that's true, you also need to find something that's false. For example, when 2 6-sided die are rolled, there are 36 possible outcomes that you can get. But let's get a little more specific with what we want to find, okay? Out of these 36 probabilities, if I want to find ones that the sum does not equal to 6 to, I would use this equation. P times the sum is not 6 equals 1 minus sum is 6. Okay, so we're going to flip it around. It will be 1 minus 5 over 36. 5 are all the ones that do equal 6. And over 36, all the possible outcomes. Subtract that by 1, then it's 31 over 36. We all know the fraction 31 over 36 is 0.861. Just like that. That's 0.861%, roughly, is your probability of getting a die that does not equal 6.
Wait, you're going too fast.
Let's try another one. If I want to get one where the sum is less than or equal to 9, first I need to find out which one is greater than 9. All right? So greater than 9 would be 6. Only 6 of them out of 36. Subtract that by 1, you get 30 out of 36. And then that simplifies to 5 over 6. Obviously, we all know that the fraction is 0.833. That is 0.833% that you get a die where the sum is less than or equal to 9.
Does he always move this fast?
Yeah. Hey, you've been doing a good job following along, though. Here's his hat.
Wait, but that's what Brian's been wearing.
I'll tell you, I know that son of a mathematician for 17 years. One day, he's gonna be a teacher.
But isn't that what he's doing right now?
Do you remember area? Yeah, that little annoying thing. Well, we can use it for probability, too, to solve circles.
How?
By using your face!
He's not being a teacher with that attitude.
Who are you talking to?
Ike, he's right here.
Anyways, this is a dartboard. Let me ask you a question. What is the first thing that comes to your head when you see a dartboard like this?
A dart to hit it with?
Wrong! You should be thinking about what the probability is that you hit a bullseye and what the probability is that you hit it all the way over to the front yard. Well, our equation is this. P times 10 points equals the area of the smallest circle divided by the area of the entire board. And now our equation comes to pi times 3 squared over 18 squared, which is the entire board, and this is the board of 10. Now that simplifies to 9 pi over 324. That simplifies to pi over 36, which of course, everyone knows. It's 0.0873. Everyone knew that. Everyone knows. And that is the probability that you are going to hit a bullseye. You also might be wondering, what's the probability of you getting 0? Or in other words, throwing the dart across the Grand Canyon and hitting a caterpillar at the bottom.
I wasn't wondering that.
Of course you were. Now, instead of taking the area of the entire board, we're going to take the area...
outside the larger circle?
No, the caterpillar down at the Grand Canyon. Of course the outside of the larger circle!
Hey, you know what?
So here's the math. I'm not going to do the equation for you because that's boring. But our percentage is 0.215. But if anyone who pays attention to numbers notices that 0.2 is bigger than 0.8, that means you are more likely to hit it outside of the board than you are to get an actual bullseye. I'm sorry about him. He gets like this sometimes.
Oh, no, you're good, unless you have something to do with it.
Oh, no. I don't tell him to quiet down when he does it.
You know, I think you're missing a bit of courage. I mean, him confronting you, if that's the only thing that's stopping you from pointing out his crash outs, he might be taking advantage of you.
You know what? Maybe you're right. Thanks for giving me that advice.
Well, sure. I mean, it's just an observation.
Here, take this hoodie.
What? Dude, why do you keep giving me all this stuff?
All right, follow me. So what do I look like?
Dude, you look great. Also, I want you to call a guy real quick.
A guy? What do you mean a guy?
There's just been this dumb guy who sits on his bed all day and does nothing. I want you to teach him a little lesson.
And you want me to do that by calling a guy?
Yeah, I feel like you could be a better teacher than Brian ever will be. Here, call him.
Hello? What's up? Really? That sounds like fun. Wait, you mean the Hayward Mall? Oh, okay. No. What time can we meet? Okay then. Bye.
Now we just gotta go over to his house and show him what he's doing wrong with his life.